Hello, my name is Bruce Whitfield. This is ECN 424, Section 1. This is the finite state machine, the first major component for Project 2, the traffic light controller. I have the entity set up here with clock, reset, short, long, and car waiting as 1-bit inputs. Short and long stand for the short and long time interval, and car waiting stands for the car sensor that's on C Street. I have an output start timer that's 1 bit, which will be an input into the timer to signify for it to start. I have a traffic light 15-bit output, which will be pin planned to the base 3's LEDs to signify the traffic lights. There are 5 lights, and A north has red, yellow, green, green turn, yellow turn arrow. And I encoded those 5 bits to 3 bits, and then I have the 3 bits for A south, 3 bits for A B east, B west, and 3 bits for C Street. The sequence of the lights goes red, yellow, green. So the most significant bit is red, yellow, then green. And then I have a 4-bit output for light display, which will be an input into the VGA monitor to signify what needs to be displayed on the VGA monitor. I have the architecture set up, the behavior of the finite state machine, with 2 temp signals, one for the light display, one for the traffic lights, and then I created a type called state type that has 8 different states, and then a signal current state, next state of state type, and then a signal for start timer. I have a process with clock and reset in the sensitivity list. If reset's equal to 1, then current state stays 0. If a clock event happens and at the rising edge, then current state is equal to next state. I have a process with current state, next state, car waiting, short, and long in the sensitivity list. And then I have a case statement here with current state in the as a selector. When in state 0, I set the start timer to 1. The traffic lights I set to 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0. Basically, when it's 1, 0, 0, that for A south, B east, B west, and C Street, that means it's red. When it's 0, 1, 0, that means it's yellow, and when it's 0, 0, 1, it means it's green. A north, the 5 bits are encoded, so through the video I will just explain the bits, the 3 bits for that, and then let you know the status of the other streets. So in state 0, you have 0, 0, 0, which stands for A north, green, turn green. The rest of the streets are red. I have the light display set to 0, 0, 0, which would be the first display. If the short time interval is reached, next state is state 1. When in state 2, I have the 15-bit output for traffic lights set to 0, 0, 1, which stands for A north, yellow turn, A north, green, yellow, turn. The rest are red. If the short interval is reached, next state is state 2. When in state 2, I have the 15-bit output for traffic lights set to 0, 1, 0, which basically means A north, green, and then 0, 0, 1, which stands for A south, green, with the rest of the lights red. The light display is set to 0, 0, 1, 0. If the long interval is reached, the next day is state 3. When in state 3, I have the 15-bit output for traffic lights set to 0, 1, 1, 0, 1, 0, which stands for A north, A south, yellow, with the rest red. The 4-bit light display is set to 0, 0, 1, 1, which is the fourth display for the VGA monitor. If the short time interval is reached and car waiting is enabled, then the next day is state 6. If a short interval is reached, then and a car isn't waiting on C Street, the next day is state 4. When in state 4, the 15-bit output is 100, 100, 001, 001, 100, which stands for basically B East, B West is green, and the rest are red. If the long time interval is reached, the next state is state 5. When in state 5, the time 15-bit output is set to 101, 100, 010, 010, 100, which stands for all the lights being red except for B East, B West being yellow. If the short time interval is reached and a car is waiting, then the next state is state 6. If the short interval is reached and a car isn't waiting, the next state is state 0. Now, when in state 6, the 15-bit output is 110, 110, 110, 110, 001, which stands for all the lights being red except for C Street being green. If the long time interval is reached, the next state is state 7. When in state 7, we are going to have, one moment. We are going to have, the 15-bit output 111, 100, 100, 100, 010, and that signifies all lights being red except for C Street being yellow. If the short time interval is reached, the next state is state 0, and then I end the case and process, and I end my architecture.